Good evening or good afternoon, everybody.
This is your review sheet for Chapter 2, Sections 5 and 6. You can see we're differentiating with x's and y's in here. So let's go ahead and start with number 1 because my time's limited with this recording. So the derivative of 6, which is a constant, is 0. Over here I have the derivative of x squared, which is 2 times pi, x to the first. Since I took the derivative of an x, I write that as dx dx, plus, and then 3 times 7 is 21, y squared, dy dx. Okay, now we're going to isolate the dy dx, and that'll be our final answer. So I subtract over 2 pi x, dx dx goes bye-bye. This is equal to 21y squared, dy dx. So let's divide over that 21. So this is 2 pi x divided by 21 y squared, and that's it for dy dx in number 1. That would be finished. Okay, here we go after 2. Looks like we have product rule in a couple spots. So I'm going to think of this as 2 times x to the first times y to the half. So I'm going to take the derivative of x first, which would be 2 times 1, which is 2, y to the half. I took the derivative of the x here first, so that's what I'm doing here. Now I'm going to rewrite 2x times half, y to the negative half, and I took the derivative of y to get that, so that's dy dx. On the right side, I have another product rule here, so this is going to be 6xy dx dx plus, and then the derivative of y is 1, so this would be 3x squared dy dx, because the derivative of y is 1, and 1 times 3x squared is 3x squared, plus 0, because the derivative constant is 0. Alright, so let's do some simplifying here. This is 2 times y to the half, plus xy to the negative half, dy dx, equals 6xy plus 3x squared dy dx. So it looks like I'm going to move this over here. I'm going to move this over here. So this is 2y to the half minus 6xy equals 3x squared dy dx minus xy to the negative half dy dx. All right, GCF. On the right, it's just going to be dy dx because that's what we're trying to isolate. This is for 3x squared minus xy to the negative half. Okay, I'm going to divide this. Okay, divide this. All right, so this is gone, and this is my dy dx. That's my final answer. Yes, I can pull out a 2y. And that's going to leave me with, a 2y to the negative half and minus 6x. They're not going to be like terms, okay? So there's no reducing I can do from pulling out the GCF, so I'm going to leave it as is for now. All right? So let's jump to 3 and 4. Okay, so here we go with 3 and 4. Starting with 3, do the derivative of this, which would be 10y fourth dy dx. I got product rule here, so the derivative of x is 1. Y cubed dx dx plus 3xy squared dy dx. This is going to equal 1 dx dx plus 0, because the derivative constant is 0. So let's go do some housekeeping here and distribute this minus in. So 10y to the fourth dy dx states this is minus y cubed minus 3xy squared dy dx equals 1. 1 plus 0 is 1. Okay, so dy dx is going to stay over here. In fact, I'll pull a GCF because I'm keeping them out over here for a while. This will be just 10y to the fourth minus 3xy squared. I move this over. I'm going to move him over, so this will be 1 plus y cubed over here. All right, so dy dx is looking like 1 plus y to the third, and then this is going to be 10 y to the fourth plus 3xy squared. Yes, again, it's tempting to want to cancel out a y, but you can't because this one does not have a y. So if you really wanted to reduce it, you'd have to break it apart and go from there. let's go ahead and look at our trig function here in 4. Let's start with chain rule. So this is going to be the derivative sign first. This will be 23 times the cosine, 2/3 y, times the derivative of the inside, which is 2/3 dy dx, because I finally took the derivative of y here, equals 1 dx dx, because I took the derivative of x. All right, so it looks like we have a lot of stuff going on here. We've got 23 times 2, so this will be 46 cosine 2/3 y all over 3 dy dx equals 1. I'm going to multiply by the reciprocal. 3 over 46 cosine 2/3 y times 3 over cosine 2/3 y. Yes, I need the 46 here as well. So dy dx is equal to 3 over 46 cosine of 2/3 y. Alright, and that's that. Okay, I'm going to get set up for 5 and 6. Here we go on number 5. I could rewrite 5 in order to do like product rule, but since I think some of you need to see quotient rule, I'm going to leave this as is. I'm going to do quotient rule. So derivative y is just 1 dy dx. Derivative at the top is negative 7 dx dx times 2x minus 1 to the 5th. Minus, so this is the derivative at the top times the bottom. Now I rewrite the top, which is negative 7x, times the derivative of the bottom, which would be 5, 2x minus 1 to the 4th, times 2 dx dx, all over 2x minus 1 to the 5th, which is then squared. So this is nice that dy dx is already by itself. This is going to be negative 7, 2x minus 1 to the 5th. Over here, this will be 2 times 5, which is 10, times that. So that's plus 70x, 2x minus 1 to the 4th, all over 2x minus 1 to the 10th. So it looks like everybody has a GCF of 2x minus 1 to the 4th I can get rid of. So this will be negative 7 times 2x minus 1 plus 70x, and he's gone completely. So I'm reducing 2x minus 4 to the 4th. This becomes 1, and this becomes 6. Over 2x minus 1 to the 6th. Now I'm going to combine like terms up top. So dy dx, this will be negative 14x plus 70x. That would be plus 56x plus 7 over 2x minus 1 to the 6th. All right? That way I combine like terms. I think we're good there. 70 minus 14 is 56. All right, let's jump over to 6. All right, start with 3 cosine squared 4x to the 3rd times negative sine 4x to the 3rd, times the inside now, which is 12x squared dx dx. This will equal, this is 7 dy dx. So we have all this stuff multiplied together here. So that would be 12 times negative 1 times 3. So that's going to be negative 36 cosine, got my x squared. Okay, so I'm going to go ahead and write my x squared here as well. Cosine squared 4x cubed sine 4x cubed. Dx dx cancels out, and then I'm going to have dy dx here. Now, how do I move 7 over? I basically divide this. 36 is not divisible by 7, nor is that reducible. You can keep it as is. All right? Let's pause this, keep moving. All right, let's take a look at number 7. We're now finding the slope of a given point for this equation. So we have to derive this. All right, so that looks like it's going to be a lot of fun. So to start, this is 4x to the third dx dx plus, now I have product rule in here. So this is going to be 2x y cubed dx dx plus, now I have 3x squared y squared dy dx plus 2y dy dx, and that equals 2 dy dx. So now we're going to get all dy dx's on one side. I think I'm going to get everything on the right. Okay? So this 4x cubed is going to stay. That dx dx goes bye-bye. This is going to stay, and that's 8xy cubed. Right? And everything else must go. So 4 times 3, that's 12. So I'm going to subtract that over, and I'm going to subtract this over. So basically I have 2 dy dx minus, remember 4 times 3 here, 12x squared y squared dy dx. And then I subtracted this over as well, so it's minus 2 dy dx. Now, everything looks like it's divisible by 2, so I might as well just take care of that as we are. So this is 2x to the third. This is plus 4xy cubed. I'm going to pull out my dy dx. And since I divided this by 2, that's 1. Divide that by 2, that would be 6x squared y squared. Dy dx is gone because it's up front. Minus, this would be 1y. All right? So, to finish this up, dy dx will equal 2x cubed plus 4xy to the third over 1 minus 6x squared y squared minus y. All right, now slope. That means I need to plug in my x's and y's. So 1 goes in. So I have 2 times 1 to the third plus 4 times 1 times negative 1 to the third over 1 minus 6. This will be 1 squared. Negative 1 squared minus negative 1. So this will be 2. Because 1 cubed is 1 times 2 is 2. Plus, this is negative 1 yet, so that'll be minus 4 over. So it'll be 1 minus, that'll be positive 1, 6. So that is 6, and this will be plus 1. So we're looking at negative 2 over negative 4. So our slope at that point is a half. All right? Here's 7. All right, finally finding the tangent line. So now we got to do derivative, slope, and find the tangent line. Good news is this is a little bit easier to derive. This is 4x dx dx minus 2y dy dx equals 0. So this is 4x equals 2y dy dx. And divide by 2y. So this is 2x over y dy dx. All right, so let's go ahead and get our slope. So we got 2 times 5 over 7. That's our slope. So this is 10 over 7. All right, now let's go ahead and solve for our b. So 7 equals 10 sevenths times 5 plus b. All right? All right, so we got 5 times 10. This would be 50 over 7 equals 49 over 7. So b will be negative 1/7, and that's all said and done. Because I subtract that over. So my final equation is 10 sevenths x minus 1/7. All right, and that's your tangent line. All right, this last one I'm going to try to go through quickly. Notice you can keep your answer in dy dx form. All right, so I'm going to get this started. There you go. So dy dx will equal 2x minus 3 all over 12y to the third. I'm going to derive this now, which will be quotient rule. So I'm going to pause it here, get the work up, and explain it in a second. All right, so I took the derivative using quotient rule here. You can follow along. Derivative 2, rewrite the bottom. Derivative the top, bottom times the top here, and square the bottom. Notice I had a GCF of 12y squared here, so I pulled it out and then reduced the numerator and the denominator there. All right, notice it said leave dy dx. That's what it said. So, hey guys, see me in class. If you have questions, I'm here to help. All right, just take your time, work through it, and you should end up where you are.